All right, so we have two fire stations in a certain town. They respond to calls in the northern half, and the other one responds to calls in the southern half. So we have two different samples right away. So right from the jump, we know that this is a two sample T scenario. It's not a matched pair scenario here. All right, response time is measured by the difference in the time an emergency call comes from the fire station and the time the fire truck arrives at the scene of the fire. Fine. Data were collected. So we have a random sample of 50 calls from the first one, from the northern fire, so 50 from the northern, that has a mean of 4.3 minutes, standard deviation of 3.7. Then we have the southern fire station, 50 calls again, mean of 5.3, standard deviation of 3.2. Construct and interpret a 95% confidence interval for the mean difference in response times, the difference in mean response times between the two fire stations. So once again, because we don't have like the same people calling to each fire station or anything like that, these are just two totally independent samples, okay? So if I'm going to start to panic, so my parameter of interest, all right, we are looking for the difference in mean time response times between the two fire stations. So the true average difference in response times between the two fire stations. You can just say, if you want to put it into context, the north and the south fire stations. All right, A is for assumptions and conditions. So we're going to have the north and we have the south. All right, so random comes first. We have a random sample of 50. And same thing in the south. It's given that we have a random sample of 50. All right, for independence, we're going to say 10 times 50. So assume more than 500 calls. Same thing over here, 10 times 50. Assume more than 500 calls. And that's for independence. For normality, we don't have raw data, so we can't do a normal plot. The question doesn't say anything about normality, but we have a sample size of 50. So for normality, 50 is greater than 30, CLT applies. Same thing over here. 50 is greater than 30, so the CLT applies. All right, the name of this is a two sample T interval. All right, let's go ahead and figure out the interval. So the general formula, it's the mean of the north minus the mean of the south, plus or minus the t-score. For standard deviation, once again, just hop over to your formula sheet. And it is right here, okay? So for two different populations. So S1 squared over N1, S2 squared over N2. So it's a square root. So standard deviation of the north squared over sample size for the north, plus standard deviation of the south squared over sample size for the south. And then we go to our calculator. Stat test, this is a two sample T interval. We have stats, we don't have data. We do not have data. So anyway, the north is 4.3, standard deviation of 3.7. Sample size is 100. For the south, 5.3, standard deviation of 3.2. Sample size 50. I'm sorry, not 100 is the sample size. 50 is the sample size. Good Lord. Pooled, confidence interval is 95%. Pooled is a big old no. and then we calculate it. Degrees of freedom is 96. And our interval is negative 2.37 to 0.37. So DF is 96. Our interval is negative 2.37 to 0.37. For our conclusion then, we are going to say I am 95% confident that the difference in average response time from the northern to southern fire stations is between negative 2.37 and 0.37 minutes. Part B, does this confidence interval in Part A support the council members' belief that the two fire stations have different mean response time? Well, if we look at our interval, the interval does include 0. And also, so like in this case, a negative value represents the north side being faster. A positive value represents the southern time being faster. Both of those exist. So this is where you're going to do your, I could say with 95% confidence that 0, which does represent no difference, being a plausible value, is in the interval. We cannot claim that there is a difference. So once again, just to write that out, that's from a different problem. Since 0, which represents no difference in mean response times, is included in the interval, I can't say with 95% confidence that there is a difference in mean response time. Once again, I'm not saying that there's no difference. I'm just saying we can't claim anything.